All right, thank you for joining us for video explanations of the practice problems for day 2. So we're going to write each function in factored form and hence determine the type and equation of each asymptote. All right. Technically, we don't need to write the factored form to determine the type in each, but it's good for practice to get the factored form, right? Because technically we could come over here and say, hey, we're going to have a slant asymptote or an oblique asymptote um, for the first one, and that's going to be because the numerator has a larger power than the denominator, right? We'd have to do work to figure out that slant or oblique asymptote, but we know it's going to be slant or oblique. Here, numerator and denominator have the same degree, and so I know that I'm going to have a horizontal asymptote of y is equal to 1. For this one over here, I'm going to have, if we look to this, right, numerator larger degree than the denominator, so that means I'm going to have an oblique asymptote. Right. Now, the reason for writing these functions in factored form is because it will make your life easier to recognize if we might simplify. Right? And if I might have a removable discontinuity that would result in not having a slant or oblique asymptote possibly. Okay, so for the first one, if I factor, this would be x plus 3 times x minus 1. Denominator factors to be 3 times x minus 2. And so I know I'm going to have a slant or an oblique asymptote, and it's going to be based on what happens if I divide by my denominator. And I could do the long division if I wanted to, or I could say, hey, my denominator will have a root with x equals 2. And so I could say, hey, well, I'm just going to work with the root of x equals 2, do synthetic division, and multiply. And so I know that my slant asymptote or my oblique asymptote, and I have to write it as an equation, right? That equation is going to be y equals x plus 4. Right, no A is good for oblique asymptote. Right, for this one, factored form, the numerator factors to be x plus 3, x plus 1. The denominator factors to be x plus 1, x minus 1. And so that's going to give me a simplified form of x plus 3 over x minus 1. Like we said, we have a horizontal asymptote of y equals 1, but it says the type and equation of each asymptote, and so I know I'm also going to have a vertical asymptote of x equals 1, because in simplified form, my denominator is 0 when x equals 1. Knowing that, I recognize that I can come back to part A and say, hey, I did also have a vertical asymptote, and that vertical asymptote was x equals 2. So getting into factored form allows you to get into a simplified form from which you can get all of your asymptotes. Okay, for this one over here, let's see here. I'm going to do the work down here just a little bit. So I have an x squared term for my first two, which gives me x minus 2. I could factor out a 3. That gives me an x minus 2. All right, and the denominator is going to be x minus, let's see here, so x minus 4 and x minus 2 from the denominator. Let's clean that up. And so I see I have an x minus 2 in common from my numerator and denominators, right? And so the x minus 2 will reduce because every term has it. So that's going to give me x squared plus 3 in the numerator, x minus 4 in the denominator. And so I know that I have a slant or an oblique asymptote, but I also know I have a vertical asymptote of x is equal to 4. And to find that oblique asymptote, like we said, I could just do synthetic division. And with that synthetic division, I really don't care about the remainder. That I know that the oblique asymptote will be y equals, happens to be x plus 4 for this one as well. So this particular graph will have a hole. It'll behave like the graph of x squared plus 3 over x minus 4, oblique asymptote of y equals x plus 4, vertical asymptote of y equals 4. So it's pretty straightforward. Factored form helps out a lot. Okay, let's look at a couple more with the same type of idea. And so we're going to identify these key features for each function. So get our factored form. Numerator factors to be for this one doesn't factor the numerator, right? So I'm just going to have x squared minus x plus 4. And the denominator, I'm going to have 2 times x plus 1. And this one over here, let's see here. 6 times 5 is negative 30. So this could be written as 6x squared plus 10x minus 3x minus 5, which if I look to group things, I could factor out a 3x and have a 2x minus 1, and I look to factor out a 5, and that would give me a 2x minus 1. And the denominator is 2x plus 5, so this is just going to be 3x plus 5 times 2x minus 1 all over 2x plus 5. So neither one of these has any holes. I don't have x plus 1 as a factor of the numerator, or do I? Let's see here. X squared minus x plus 4. Oh, no, that, yeah, no. If it's plus 4, it's not going to, what if I change that to be minus 4? If that was minus 4, no, that wouldn't do anything either. So we'll leave it as plus 4. So x squared minus x plus 4. All right. So holes, no holes for either one of these. It's fine. Vertical asymptote, x is negative 1. Vertical asymptote, x is negative 5 halves. Horizontal asymptote, larger power in the numerator, not applicable. Horizontal asymptote, larger power in the numerator, so not applicable. Oblique asymptote, right? Oblique asymptote, I would need to do my synthetic division, and 1, negative 1, and 4. And once again, I don't care about the remainder, so bring down the 1, negative 1, negative 2. So my oblique asymptote is y equals x minus 2. Here I have negative 5 halves, so I'm going to work with negative 5 halves. Not going to be easy with a fraction, but we'll make do. All right, so bring down the 6. Multiply, 6 divided by 2 is 3, so that's negative 15. Add negative 15 and 7, so that's going to be 8. And once again, I am not concerned with the remainder. I just care about this piece, and that actually should be a negative 8. 7 and negative 15 is negative 8, so my oblique asymptote is y equals 6x minus 8. Right, x-intercept is going to be when the numerator is equal to 0. Right, so let's come over here and just identify our discriminant, b squared minus 4ac. For this one would be 1 minus 4 times 1 times 4. And so that is less than 0. So I don't have any x-intercepts. Here, my x-intercepts would be at x equals negative 5/3, right? And we're at x equals 1/2. Of course, if it was told to give the coordinates, that'd be negative 5/3, comma 0, right? Or 1/2, comma 0, if I had to give the coordinates. Y-intercept, if I set x equal to 0, if I set x equal to 0, this one reduces to 2, so that's going to be 0, 2. If I set x equal to 0, all of that's 0, negative 5 over 5, so that is going to be 0, negative 1. All right. Domain, just exclude the denominator being 0 before you simplify. So all real numbers, x is not negative 1. And over here, all real numbers, x is not negative 5/2. Okay. Key features that we need to be able to do, that's the major focus of this lesson. Please ask questions for clarification as needed.